and good day. Today in Algebra, we'll be going over CO6, which is writing, interpreting, and evaluating what we call algebraic expressions. So the first word we have to define here is expression. And not talking about facial expressions, because can't see those today anyway. But what is a mathematical or algebraic expression? Colin? It is actually very much unlike an equation because the difference between an expression and an equation is that an equation has that equal sign, right? It has value. An expression just states something. So 6 plus 3, that statement is an expression. Once we apply the equal sign and say, okay, it has the value of 9, now we've turned it into an equation. So an expression is basically an equation without that equal part. Okay? We define it as a mathematical statement. Like that. Yeah. Math teacher and 5th grade spelling bee classroom champion and 6th grade spelling bee classroom runner-up.
Okay.
How about variable? How would we define variable, Sebastian?
A number something in an equation that is not expressed by a number.
Ooh, something in an equation not expressed by a number. Someone kind of give me another definition there we could use for variable. Luke?
Sometimes it's a letter, but it can always be changed or added on to.
Okay, so a variable is basically an unknown value. Usually it is represented by a letter, most commonly X, Y, Z, or N. In area formulas, we have like B for base, H for height, right? So it's an unknown value or something that can be changed. In science class, whenever you do an experiment, you've got to identify your variables, those things that you can't control or that you're changing in the experiment, right? In a math expression, it's that unknown value that usually represented by a letter. So to do this, we're going to kind of tackle the challenge of word problems today. Many students feel like word problems are kind of the hardest part of the homework assignment. You always dread, how many word problems are there? Oh, 3. Woo! Okay. And what makes them challenging is that it can be difficult to identify what they're saying. Okay, what's the important information? What can I ignore? What does this mean? What operation is it? What's my equation? So we're going to kind of try and solve that problem today. Yeah, Luke.
I'm pretty sure we went over this last year a little bit.
We are still in the review realm. Yes, yeah. This first unit should be the review realm. So good, very, very good. Well then, Luke, start us off. What are some words or phrases? You can start anywhere you want that would belong in this table.
Well, I'm going to do an easy one, multiplication.
Okay.
It is like anything, like it's like let's go for 2. 2 times a number.
Okay, times. When you see the word times, your brain should go to multiplication. Okay. What else, Catherine? Difference with subtraction. Good. The difference between two values, how far apart they are. McKenna? Quotient for division. Is there a hand up over here? Camden?
Times. Or sorry, I meant sum. Like twice.
Like the sum of a number.
Yeah.
The sum goes under addition. Yeah. But you also said twice, and you're right. Something like, twice or triple, that would be under the multiplying by 2. Triple is multiplying by 3. Okay. Yes. Wear the glasses. Lily. Product for multiplication. Product for multiplication. Griff. Minus for subtraction. And there's actually two I want to make sure that we talk about with subtraction. So put your hands down for now. Subtraction can be kind of confusing because with subtraction, order really does matter. Okay, if you've got the phrase less than, I want you to write that down and then I want you to star it. Because when you see that phrase, you've got to be very, very careful. Right? If I wrote over here, if I put 10 less than 8, okay? 10 less than 8. As an expression, why is it negative? Who blurted that out? Nick.
It's negative because it's the 10. Because the 8 is first. Technically, if you wrote it out as an expression, the 8 or a equation, the 8 is first, subtracting by the 10.
Yeah, the temptation here is to write this as 10 minus 8. Because 10 less than means subtraction, and then we have 8. But when you think about what it's actually saying, 10 less than 8 means we're starting with 8, and we're taking 10 less than 8. Okay, which is actually written as 8 minus 10. So for the person who said, hey, that's negative, they're right. 8 minus 10 does equal negative 2. Okay, so when you see that phrase less than, you really got to be careful with the order. Okay, the other, yes, Luke.
Well, there's one on our homework. It's like less than the product.
Yep, we'll get down there. We're still on the table here. Okay, the other subtraction phrase that I want you to be wary of is subtracted by versus subtracted from. Subtracted by versus subtracted from. So we're going to star this one too. Subtracted by versus subtracted from. Because if I said 10 subtracted by 8, 10 subtracted by 8 would be 10 minus 8. If I said 10 subtracted from 8, now we're back to that 8 minus 10. Okay? So 10 subtracted by 8 would be 10 minus 8. 10 subtracted from 8, that order changes and it's actually 8 minus 10. Right? So be very, very careful when you see those phrases. Make sure you're putting them in the correct order there. Lily, go ahead.
For addition, more than.
More than is under addition. I don't understand why that is said every class period. Just, Catherine. Sorry? Plus for addition, yes. Division's feeling left out. Is there any? Yeah, Nick. Of, that's a good one. Because of is associated with the word groups. And groups of means that you're multiplying. Okay. Into groups is division. Okay. Dividing a whole into groups or into parts, division. But that word of oftentimes is associated with groups, but you've got to be careful because groups can also be division if it's preceded by into. Yes? Divided by. McKenna, is that what you're going to say? Okay. Any others? Yeah? Good. Half. Kind of the opposite of twice, Half is dividing by 2, third dividing by 3. Okay, there is one more. Do we have one more for addition? Added to would be the grammatically correct way. Okay, good. Ooh, boy. Whoa.
They weren't wrong on those surveys.
They were not wrong on those surveys. That comes through really well on YouTube too. That's good. So our job now is to use this table, use these phrases to help us with writing things going from the verbal to the numerical. Okay. And on the second page, going from the numerical to the verbal and then evaluating. So if we have the quotient of 16 and a number, you read that as a verbal phrase. The quotient of 16 and a number, what operation are we talking about here? Catherine? Division, right? That's what quotient means. What are we dividing? What's being divided? 16 and, well, when we plug in 2 for n, but 16 and a number. So when you write this as an expression, you can either go horizontally, 16 divided by n, or you can go vertically, 16 divided by n. Either one's fine. They both mean the same thing. Because when we plug in 2 for n, it becomes 16 divided by 2, and we get 8 as a value. So for each of these, you are writing them as an expression, and then evaluating when n is 2. I want to talk about the second one here, the next one down. 12 times a number minus 3. We see a comma there, and commas play an important role. Because if I'm just telling you, write me the expression 12 times a number minus 3. It could be 12 times a number minus 3, or it could be 12 times a number minus 3. Right? Both of those kind of show that same thing. Okay? And they have different values. Like we saw in our homework for today, adding parentheses can drastically change values here. So when you see a comma in a statement, that kind of means like pause, right? Like take a breath. So it would be 12 times a number minus 3. That's what we're trying to figure out. Okay? So if I say, write the expression 12 times a number minus 3, which one am I talking about? The top or the bottom? 12 times a number minus 3.
The bottom.
The top one. Right? Because the bottom one has the n minus 3 together. The bottom one would be if I said 12 times a number minus 3. I'm separating the 12 and the number minus 3 with a comma there, versus the comma after the word number says you're taking 12 times a number, pause, minus 3. Okay? So with commas, just like with kind of less than and subtracted by versus from, you've got to pay attention to what is it breaking apart. Let's look for another one with a comma here. This last one says the total of 22 and a number, comma, divided by 6. Is this saying the total of, why am I on an eraser? Oh, sorry. Is it saying the total of 22 and a number divided by 6? Or is this saying the total of 22 and a number divided by 6? Which the comma where it's at, after the total of 22 and a number, what is that comma separating? Linnea. So is it the first one or the second one? It's the second one. The total of 22 and a number, comma, take that, stop, pause, and then divide by 6. So commas do serve an important purpose here. Okay? They are used to kind of stop, pause, finish this, and go for it. Okay, I'm holding. Our final step here, before I get to you, Olivia, the final step here is to evaluate when n is 2. So we would plug 2 in for n, 22 plus 2, or 24 divided by 6, we would get 4. Olivia. I can. So twice the sum of a number and 6. Okay? Twice means what? Not squaring, but multiplying by specifically 2. Okay, so we got times 2 there. The sum refers to the answer to an addition expression. Okay, so twice the sum of a number and 6. That means we want to find the sum first. What are we twicing? What are we multiplying by 2? We're multiplying the sum by 2. So that sum, because we have to find it first, should be in parentheses. Okay? And then multiplying that by 2, you can put 2 out in front. You can put times 2 afterwards. So it's like, n plus 6 times 2. That's fine. Okay, but that word sum, we do need to put parentheses around it because that's what we are doubling. That's what we're taking twice of. Luke. I'm going to let you kind of work through the rest of them. Okay, we've done 4 kind of as examples here. I'm going to let you kind of practice with the rest. Olivia, do you have another question? Yes. So when n is 2, 2 plus 6 is 8, and then you're taking twice that, so you would get 16. Okay. On the second page, there's another one. Wait, there's more, right? But wait, there's more. In this case, I'm giving you the numerical expression, and I would like you to write the verbal phrase. So kind of the opposite of what you did on the first page, right? What would you like to do together? Pick one that looks fun. Luke.
The bottom right one.
Funny, the other class picked the exact same one. That's crazy.
Why?
I did not expect that. Okay, so this last one here has got quite a lot going on. We've got parentheses. We've got 3 different operations here. Who would like to take a try at this one? We are doing the last one. That was the one that was selected. Sebastian. Whoop. We'll leave you in suspense. Hold on. Sebastian, you were just about to tell us what your thoughts were on this last one.
The sum of 43 less than a number and a quotient of 5 plus 6.
You've got a lot of good parts there. You kind of threw me off when you used the word sum to describe 43 minus n here, since that is subtraction. But you did say quotient, okay? And so what are we dividing here? What's being divided? You could actually start this by saying the quotient of, right? Because if we were to write this as a fraction, a vertical division, we would have 43 minus n as the numerator and 5 plus 6 as the denominator. So we are taking the quotient of something, of 2 things, right? So the quotient of, where would you go from here? McKenna?
The difference of 43 minus n.
Okay, the quotient of the difference of 43 minus n, and what's the second piece of this? You can put n, it's fine. If you want to write a number, want to write n, either way. What else is being divided here? The quotient of the difference of 43 minus n, and what's the other piece? Hammond?
5 plus 6.
Probably best way to write that would be the sum of 5 and 6. I heard someone say this is confusing. Well, you did pick the hardest one to go over together. So there is that piece to it there. Okay, but yeah, I mean, this is really wordy, right? But we do have a lot going on here too. You could, if you didn't want to make it quite this lengthy, you could say 43 minus n, comma, divided by, comma, 5 plus 6. I mean, with those commas, yeah, 43 minus n, comma, we're taking a break, divided by, comma, 5 plus 6. That would also work, right? So you as long as you're identifying the operations going on here and separating what needs to be separated, there's several ways that this could be written out. Yes, go ahead, Lily.
Oh, I said the difference of 43 and number divided by the sum of 5 and 6.
Great. Yep, good. Good. Okay. You do then need to evaluate this when n is 10, so you would plug in 10 for n. You end up with 43 minus 10, which is 33, divided by 5 plus 6, which is 11, and so it has a value of 3. Okay. You do have till Thursday to finish this assignment, since tomorrow we are going over the math packet. So it's It's a bigger assignment, but you have an extra day. Mackenzie, like the month and allowance one? Yeah. Before we get to that though, any other things on this? Griff.
Not on this, but is the practice test is that due or is it just like?
The practice test is treated like a homework assignment.
Okay.
Yes, go ahead, Lily.
The third one down on the left. 1/2 times n.
Did Mackenzie already ask? You just said it, so now you're trying to write it.
So 1/2 times n minus 10. Identify what's going on here. You are taking half of a number. And then what are you doing after that? Perfect. Okay. Mackenzie asked for the very last section on the page here with the allowance. Your book says weeks here, not months. A 7th grader pointed that out to me earlier today that your book says weeks. So I changed it here so future generations of algebra takers won't be confused. But for you folks, what's that? There's a 7th grade pre-algebra and a 7th grade algebra class, yeah. The goal being so next year in 8th grade, they won't have to take geometry after school. It's during the school day. Well, we're born at the right time, I guess.
So they're going after school as well?
They're not this year. Next year, they'll go in during the school
So
day.
they're just taking 2 classes in school?
No, they're taking algebra currently. No.
You said pre-algebra and algebra?
Yes, separate classes.
Yeah.
One pre-algebra group, one algebra group. But to Mackenzie's question. So for this one, it says your parents devise a plan for your allowance. They will give you $1 more than double last month's allowance. That's kind of the important phrase here, right? $1 more than double last month's allowance. So if in January you had $1 of allowance, in February you'll get 1 more than double that. How much will you get in February? 3. Double 1 is 2, plus 1 more would be 3. In March, you will take last month's allowance, which is February. You will get $1 more than double that. How much will you get? Linnea? 7. Okay, 3 times 2 is 6, plus 1 is 7. In April, you will get 7 times 2 plus 1, 15. Okay, if you do this correctly, you will find that this is a plan that you want to be on. This is a plan you want to be on. The second piece of this is to write an expression that models how your allowance increases from one month to the next. So basically, I'm asking you to take that $1 more than double and write that as an expression. What does that look like? Okay. Your homework is to complete all of CO6, both pages. You do have until Thursday to finish it, though, because tomorrow we'll be going over math packet number 2. Don't forget about Con. Con is due Thursday. And if you're in the football picks, those are due Thursday as well. So Thursday, October 1st. Week 3 standings will be out tomorrow. I left my laptop at home, so I can. All right, folks, that is how you math. That was literally your best yet. I'm so proud of you.